Today, we're going to talk about how machine learning can help DevOps teams run the tech they want at the scale they need. Quick agenda. We're going to go through an introduction to the problem so you can get an idea of who we are and why we're even doing this. We're going to show a quick demo of Vorstella, and then we're going to close it out with a Q&A session so you guys have a chance to ask some questions about what you see. Quick housekeeping before we start. We really appreciate you taking the time to join us here today. If you attend the full session, you are involved in IT or DevOps, and you've provided a work email address for registration, we'll be sending you a $20 Amazon gift card for attending today to say thanks, and we'll send that to that email address you provided. I want to start by introducing who we are and what we're doing. Like I said, I'm Avinash. Before Vorstella, my co-founder Matt and I spent several years at DataStax and then as independent consultants. And our main job and our main mission was to help enterprises adopt mission-critical distributed systems like Cassandra, Kafka, Elasticsearch, Spark, even some Kubernetes on the infrastructure side as well. And we've had a lot of great experiences between the two of us over the last few years. We've been in the central NOC with a wall full of screens on Black Friday at one of the world's biggest online retailers. We've been tier 3 support for a major consumer finance application on tax day. And just generally, we've helped design and run some of the biggest distributed system deployments out there. Things in the space were growing and changing really quickly, which was very exciting. And it was creating all these opportunities for the companies we were working with. But as we progressed through the early adoption phases from around 2010 all the way through to like 2015, we really started to see just how much strain adopting new technology can put on an organization. Now, we're typically given a few things up front, right? We're given a budget under which we have to meet our goals, and we're given those goals in the form of availability and performance SLAs from the business. And it's our job as operators and people responsible for these systems to deliver on those business requirements under budget. That means all the tools, all the licensing, all the vendor support, and all the staff and consultants that you need to make it work. For most people, this was okay when they were just running a handful of clusters and it was just starting out. And they had this team of 2 people who were really passionate about the technology, who were able to scale to what the business needed at that point. But what we saw time and again was those small successes always created a ton of demand really quickly internally. And as this tech got more popular and more developers are sort of beating down the door asking, hey, can you run this for me? We started to realize that there just weren't enough people within the company or on the market as a whole with enough expertise to successfully wrangle this tech. And a lot of teams are still in this position today, right? We want to use all the popular tech at scale in mission critical applications. And we don't want to be restricted just to one technology, right? It's specialized tech at the end of the day. But there's really no good solution for companies to get the best of both worlds under budget while also meeting their SLAs reliably. We saw a lot of people standardizing on one technology and saying that they were an HBase shop or a Cassandra shop. And that's great. Those technologies are very powerful, but if you limit developer choice, you're going to find yourself always being one step behind, always building on yesterday's tech. The other alternative is you just roll the dice. You make tech expertise the dev team's problem, and they have to handle it. They're responsible for knowing the ins and outs of the systems. You don't centralize. And that gets you going a little faster, but inevitably it's going to create risk in the enterprise. And it's really, more importantly, going to defocus developers from building new features and pull them into application support way more than they need to be. So if we look at this box here and we try to figure out how do we get all 4 of these things that you see on the screen and make them work successfully, we decided, all right, we need to figure out a way to scale expertise. So we need to figure out how to take what we're doing as consultants and essentially digitize it so that it can be done either entirely or mostly by machines. And what did we do? We just used to dig through dashboards for a long time. We would look at all the signals we're seeing. We would add new graphs as needed. Then we would apply pattern matching and knowledge of, which metrics mean what. And we would extract basically these events that we knew in our head to be important that were happening on the cluster. And once we had determined this set of events that were happening on the cluster, we would just correlate them and map them to what we'd seen before. And that's how we would understand how to address an issue we're seeing most effectively. Oftentimes, we had these little scripts we would run on monitoring data or logs. We would often ask people to run little profilers on their systems and send us that data back. And while it was really inefficient doing that back and forth, it did get the job done most of the time. And the more we analyzed this, the more we saw, and the more we thought about this, it just seemed like a very clear problem to apply machine learning to. So we built a real-time analytics engine, and it uses machine learning to learn from every deployment it sees, automate complex but also repetitive tasks like tuning, issue resolution, and just make it really easy for anyone who wants to run this popular distributed system tech to pull it off the shelf and run it in production at scale with confidence. So let's take a look at how this analytics engine works and what it can do with the data that our agents collect. Again, it's an agent-based install. So let's take a look at this product here. The first thing that I need to do before we go into visualizations, dashboards, events is, as an operator, what I care about is setting expectations and meeting expectations. Like we said, we have a budget and we have performance targets. So the first thing we need to do here is capture what you expect out of your system. Advice that we would give you is heavily dependent on your performance expectations. What is good versus bad or possible versus impossible about a cluster's behavior wholly depends on what my business is saying I need. So again, advice for strict low latency requirements looks a lot different than advice for use cases where your requirements around latency are a lot more lax. So we use these SLA inputs that you put in to drive all of our recommendations down the line. So that's step one, is setting expectations. Now, once I've set expectations, I need to start meeting those expectations. And that means hitting my SLAs. And when I'm not hitting my SLAs, understanding what's going on. So the problem with the way this is done today is most monitoring solutions just require way too much domain knowledge and customizations to set up so that they adequately present you the information you need to know. Even if you use a curated dashboard that was put together by an expert, it has a lot of key info and you have to know what all that means. What does every metric mean and represent? What do all these thread pools that all these systems report do? How does each subsystem that's part of these clusters use underlying resources? And most importantly, what metric values are normal and safe versus abnormal and risky? And you find that the more use cases under which you run the technologies, the more indicators you find could be tangentially relevant to informing you of how you're doing against your goals and telling you whether or not you might be about to violate some of those SLAs that you've agreed to. So this domain knowledge can quickly get out of control. We're talking about clusters that for every node that's running throw off between 1 and 5,000 distinct data points every second. This is exactly the type of expertise that doesn't scale in organizations and needs to be digitized and automated. So what are we doing differently? Well, we focus on visualizations that help operators quickly answer questions they're actually going to get asked. That's what our dashboard focus is. So you're going to get questions like, hey, I'm trying to access this table, but my searches are slow. Can you tell me why? Or what's our overall utilization looking like? Do you think we have enough headroom to add 50% more capacity? We help this quick read scenario by giving you a key visualization that's best for the tech you're using. You can see here, we're monitoring a Elasticsearch cluster that has 2 data nodes. And what we want to see mainly is for every index we have, so here we have a FileBeat index, we want to know how data is flowing into and out of those Elasticsearch nodes. And this sort of visualization gives us an easy way to map events to where in your system problems might be occurring. Now, we also give you these status checks. One of the issues with monitoring today is to get an understanding of basic system health, oftentimes you're required to quickly scan maybe 10 or 15 different data points to understand if you're thumbs up or you're thumbs down. And what we realize is what you care about is answering a higher level question. Are my settings consistent? If everything is identical and my settings are fine across all nodes, I don't need to go validate every one. Only when something goes wrong do I want to be notified and get detailed information behind that error. So you can see here, there's only one configuration value that is off here. And it seems that some client nodes in Elasticsearch think that there are more masters than they are. And that's reflected here in this quick node check here. Too few master nodes in an event we're seeing. So just giving you the information that's relevant to you at the time. So a quick scan's cool, and it does help you answer a lot of those high level questions, but it doesn't really give you a lot more detail, and it doesn't tell you when something's wrong. So we really needed a better way to synthesize all of this information, all these time series signals, and bottle it up in more understandable ways. And that's where events come in. Over here in recent activity, you can see the most important events in your cluster, but we're gonna go into here in a timeline view where we've logged in a lot of detail exactly what's happening in this cluster and summarized it in a way that you can actually understand intuitively. So again, other monitoring tools, right? You're gonna plot your graphs, but you're still staring at data. You still have to stitch all of it together and correlate it into useful nuggets of information. Our goal is to present those useful nuggets right up front and do all that background processing ahead of time. So again, we do exactly what we did as operators, but automate it. Correlate all these separate time series signals into those nuggets of information and present them to you so you know how to improve things. You can see over here, there are a number of events, everything from simple threshold violations, like this SLA violation up here, and basic events like we know a node restarted, all the way to insights that are domain specific and workload specific, right? Understanding Elasticsearch lets me know that I have an unoptimized query. We're telling you that right off the bat. We're giving you a description of why it's unoptimized. It's conducting a full scan of an index, which is always an anti-pattern. We also use sophisticated classification techniques where the initial statistical analysis will output some indicators, but then we roll that into a classification algorithm that outputs insights that we've seen based on data we've seen in the past. So a good example of this is a lot of the data that's coming through this cluster looks an awful lot like log indexing workloads that we've seen in the past. So if you go down here, you're going to see the output of one of those smaller event-based classification algorithms is going to say, based on everything we see, this workload pattern seems to match a log indexing workload. So again, these events are super helpful, but it's still only halfway, right? It's still taking out a lot of correlation and analysis work on a dashboard, but it's not really bubbling up all these disparate events that are happening in the system and coalescing that into a clearly understandable issue that I can do something with, right? So we know clearly something is wrong here. I have rejected searches. That's bad. I have my availability SLA at risk and I need to do something about it. But scrolling through just this set of information is going to be insufficient to answer the question. I need more. And that's why we've built this concept of issues and issue resolution. So as an operator, I want to know when a problem needs my attention and I want to know how to fix it. And when I try to fix it, is it resolved or is it still open? So what do we do differently here? The first step is knowing when something's wrong. Out of all of those events that we're tracking and creating on the back end and sending to you, not all of them are critical and require your attention. But we know from domain knowledge and from the data you've given us through those SLA inputs, which events should be treated with different severity levels. And we know that if you have rejected searches and your availability SLA is going to be at risk, we want to be able to flag that right away and you need to do something about that. So we've identified this issue, and a little anatomy of a Vorstella issue. You can see right here the issue is still open, and we've identified it with a severity level of critical. So this is a critical issue. We have some of the issue metadata over here, including the first time we saw it and the last time we saw it. This was a quick point in time violation, but it still violated our SLA, so we need to solve it. So once we know what that bad issue is, we want to understand, all right, how are we going to get from something bad happened to here's how you solve it? And the first step into that is deciding which events around that bad event are related to this problem. So when we give you a root cause, the first thing we want to give you is why are we presenting you with this root cause and remediation? And that's going to depend entirely on what input events go into our root cause classification algorithm. So in this case, you can see we've detected a bunch of things that we saw in that event stream. This is a much more easily readable, digestible form of those events that we've tracked. So we know you're indexing time series data. You're doing log indexing in your workload. We know you're a write-heavy use case. And we also know your queries contain regular expressions. And we know that regular expressions are doing something bad here, which is scanning all available indexes. So this, as an operator and as an expert who's operated this system before, I can probably do a lot with this if I have a deep domain knowledge. But if I'm more of a beginner in this system, I need someone to take me to the next step. And we run all of these events through a root cause classification algorithm. And the output of that is this identification you see here. So all of these events have determined this grouping of things that are happening in your system. You're a time series use case, you're doing log analysis, and you're doing a lot of regex queries. That is your root cause right here, this combination of 3 events. That's how that algorithm works. Now that we know what's going on and we're confident that we've identified what's going on, we can give you a remediation. And let's walk through what a remediation looks like here. This root cause is actually relatively common, so it's pretty simple for us to provide a remediation here. A remediation consists of a combination of auto-generated advice, like this first line here, and we're also able to supplement this with specific advice that is relevant to your cluster. You can see in lines 2 and 3 remediation, there's a lot more meat in there. It's not just very general, linking you out to documentation. That's because as part of our product, as part of training this root cause analysis algorithm, we see issues totally anonymized on the back end when they happen. And the machine learning algorithm maybe can't classify it as confidently as we want it to, or we feel that the remediation recommendation that we have right now that's auto-generated is not necessarily detailed enough and we need to add more context to it. So you can see here, remediation can combine auto-generated recommendations that are tied to known root causes, and they can also capture user input from us and in the future from you to really build that knowledge base of issues. And the big benefit is whoever uses this technology gets benefit from everyone else's issues, right? You see a problem, we see a problem here and we fix it for you. The next time someone else in your organization sees it, they're going to benefit from that as well, right? That's really the power of this classification and machine learning workflow. There's a lot more metadata that we attach to this so that you can just explore an issue more, which nodes were affected, related events that were critical around that time. So again, this is how we're trying to solve that problem and change that workflow from digging through dashboards and trying to correlate a bunch of information in 10-hour support meetings and really shorten that workflow and give you a fast way to go from, hey, something bad happened to this is what we did to resolve it, and capturing all that in a sort of easy to understand report. So that's it for the demo. Before we hit Q&A, I wanted to just go through a couple more things. You've seen the UI here, but I wanted to give you guys a view of how this actually works from your perspective if you're going to be installing it and using it. It's a simple agent-based install. You control everything in this dotted box. That's your environment. You're running Cassandra, Kafka, Elasticsearch, wherever you want. We don't ask you to re-platform your system just to use our technology. You can run with your own custom deployment logic, whether you're running in directly on AWS or in Kubernetes, or if you're running bare metal, you have complete control over that. It's an agent-based install. All those agents send really rich data like JMX data, stripped out logs, trace data, all that stuff gets sent up to the cloud. And that's what we use to, predict your issues, give you guidance on resolving issues, and giving you recommendations to improve performance. You can pull these recommendations and these events either through a REST API, or you can go directly to our UI and interact with them there. So a lot of flexibility. Problems we're trying to solve, right? We're trying to make teams do more with less. We're trying to get you to adopt as much technology as you want, really make the promise of open source a reality. Everybody wants to run open source, right? It has a huge strategic value, but these issues prevent people from going at it confidently. Finally, reducing COGS, right? I can't tell you how many people that we've worked with knowingly over provision by up to 50% just because they want to have a little headroom and they're not confident in operating the systems effectively. You can see how as you scale from a 10 node cluster to a 100 node cluster, that amount of money that you're dropping into over provisioning gets really untenable, and you start needing more expertise to tune your systems better and make sure you're making the most out of the resources available to you. Again, tech we support today, Elasticsearch, Kafka, and Cassandra. We're looking for more. We're looking at some stream processing frameworks. We're looking at container orchestration frameworks. These are the ones that we feel are very important and high demand right now, but we'd love to hear what you guys think about what's growing out there and what's really complicated for people to use. And that's really all I have for the presentation portion of this meeting. At this point, I'd like to pause and take questions. From Steve, what roadmap items are you working on the machine learning front? So that's a great question. I was hoping to kind of get into that. A lot of the heavy lifting for building a product like this is on the back end. And now that we're through a lot of that and we have this pipeline built out and it's reliable, our entire focus is on making machine learning better and improving usability of this system. So some of the things we're approaching and we're looking at are, what event selection algorithms can we use to enhance the way that we're tying a bad event to a series of related events? If you look at a lot of the machine learning literature, fault localization has been a really interesting application of machine learning classification algorithms. We're starting off with things that are relatively simple so that we can grow our data set and not overcomplicate it, like SVMs, like Bernoulli classifiers. But there's a whole lot of different approaches that we're investigating that are based on temporal analysis of related events that have shown a lot of promise in that space. So that's all I'll kind of get into now. We'll probably be doing another webinar going into that in more detail, and hope you can join us for that as well. Question from Roxanne: will this presentation be available post-webinar? Yeah, definitely. We're going to be posting it online. I'm guessing on our website, but I'd have to check with the marketing team on that. But we'll make sure that's available to all you guys who registered and showed up today, and anyone who couldn't make it too is going to be getting a link to that as well. We'll be posting it shortly. Question from Rajiv: how do I get started? Do you guys do POCs? Yeah, we do. So a bunch of different companies are using this right now. We're working with companies that are in industries like IT security and financial services, where they have to run their tech in-house, highly regulated environments, highly strategic, really big cogs. They really need to run all of this in-house. So we're engaged with companies like that. So we're ready to go through POCs in a couple weeks here. So if you guys want to get started, we just have to have a couple calls. You reach out through the website, fill out our form, and we'll get in touch with you same day and start talking. So if you're interested, please do go to the website and reach out. Question from Mark: how is Vorstella different from monitoring tools? That's a good question, Mark. And I think that's a really key opportunity that we've seen in our product, is the user experience of taking a monitoring tool and an unfamiliar technology that you're monitoring and getting to a baseline level of comfort with that monitoring tool could be made much better. The amount of information you have to know about what each metric means, the amount of metrics you have to graph on your charts, the amount of custom work you have to do to create alerts to understand when certain values are good or bad. It just requires so much domain knowledge and effort and maintenance just to maintain even a dashboard, that even if I were to set up, and I've been running Cassandra systems, for example, for the last 5 years, right? Even if I were to set up a dashboard for you in one of the popular monitoring tools like Grafana, you probably still need a lot of domain expertise and help to interpret what that means. So we try to take it to the next level and not just bottle up and net out what's happening in your system, but actually run those events that we're detecting through these more sophisticated algorithms so that we can tell you at a higher level, not only is this happening in your system, but here's the exact action that you need to take to meet your system goals of availability and performance. So I think that's it for questions. We are running up against time here. So again, thank you guys so much for joining the webinar. Really enjoyed sharing all this information with you. Like I said, this is going to be posted online, and we're going to be in touch with those Amazon gift cards. And please do look on our website. We're going to be posting all subsequent webinars and schedules. We'd love to see you again, and we'd love to kind of get introduced and talking to you and see how we can help you solve these problems and run this tech at scale. Thanks.